Hello, welcome to Science Excellence. Today we're gonna discuss a GCSE topic, algebraic proofs. So the question number one is, uh, prove algebraically that the sum of any two consecutive integers is always an odd integer. So first thing about this topic is that if in exams they ask about the algebraic proofs, so we don't use the specific examples for the proof. We have to suppose the given condition generally, and we have to prove that general condition and we satisfy this result. So the question is, prove algebraically that the sum of any two consecutive integers is always an odd integer. So the proof should be, let n and n plus 1 be any two consecutive odd integers, sorry, be any two consecutive integers then, and we can see n and n plus 1 be two consecutive integers because n is any integer number. I mean, n belongs to the set of integers. So for when n equals to 1, so if you sub n equals to 1 here and n equals to 1 here, for n equals to 1, so this number will be 1, so 1 plus 1, this number will be 2, so these are two consecutive integers. So in similarly, when if we suppose n equals to 2, so this will be 2 and that will be 2 plus 1 will be a next number, so 2 and 3. So it means these are two consecutive integers, and we need to prove that the sum of these integers is always an odd number. So if sum means we need to add them, so if you add these two integers, so n plus 1 will be n plus 1 n plus n will be 2n plus 1. So you can see this number is 2 times n plus 1. So 2 times n, any number times with 2 will be an even number, n plus 1, so the total thing will be odd. So that's it for this question. So hence it's proved the sum of any two consecutive integer is always an odd number. So it's very basic and easy question, but please watch the complete video, because when we move further we have most important and difficult exam style questions. Okay, let's move to the next question. Okay, the next question is, prove algebraically that the sum of any three consecutive even integers is always a multiple of 6. So now we need to suppose the even integers consecutive, and that should be the consecutive integers as well, and we need the three consecutive even integers. So let's say the first even integer will be 2n, because any number times by 2 will be even, and we need the next integer that should be even as well. So 2n is an even integer. If you add 2 to it, will be the next even number, because let's say n is 1, so n 2 times 1 is 2, and 2 times 1 is 2 as well, plus 2 will be a 4. So this number is 2 and the next even number is 4, and the next even integer should be 2n plus 6. Not 6. Two n plus, when you sub n equals to 1, this will be 2, n equals to 1, this will be 2 plus 2, 4, and 2 plus 4, so this should be 4. So if you sub n equals to 1 here, it will be 2, this will be 4, and that will be 6 when we sub n equals to 1. So 2, 4 and the 6 be the consecutive 3 even integers. So let 2n plus 1 2n plus 4 be 3 consecutive even integers. Then we need to prove that the sum means if we add these 3 consecutive even integers, that sum should be a multiple of 6. So let's add these 3 even integers. So 2n plus 2n plus 2n plus 1 plus 2n plus 4. So this is a sum of 3 consecutive even integers. So now it will be 2n plus 2n plus 2 plus 2n plus 4. So 2n plus 2n plus 2n, if we add the like terms, it will be 6n, and 2 plus 4 will be 6. So it will be 6. It is 6n plus 6. If you take 6 out, it will be 6 times n plus 1. So you can see it is a multiple of 6. So hence proved, if we add 3 consecutive even integers, and that sum should be a multiple of 6. Okay, so let's move towards the next question. Okay, the next question is prove that 3n plus 1 whole square minus 3n minus 1 whole square is always a multiple of 12. So in this question, the expression is given, we just need to work out, and at the end we need to prove that this expression is a multiple of 12. So the expression is 3n plus 1 whole square minus 3n minus 1 whole square. So if you have whole square, you can write this expression 2 times, and this expression has the power 2 as well, so we can write this one 2 times as well. So 3n times 3n will be 9n square. 3n times 1 will be 3n. So 1 times 3n will be 3n, and 1 times 1 will be 1. So we can do the term by term multiplication. So since we have a negative outside, so we should keep the bracket first and do the term by term multiplication for these two factors as well. So 3n times 3n will be 9n square. 3n times by minus 1 will be minus 3n, and now minus 1 times by 3n is minus 3n. So minus 1 times minus 1 will be a positive 1. Okay, so now we need to we can add these two. 3n plus 3n will be a 6n plus 1. If you take negative inside, so we need to change the sign inside the bracket. It will be a minus n square. So minus 3n and minus 3n will be a minus 6n, and due to this negative it will be a positive 6n, and this positive 1 will be a minus 1. And this is very important thing, if you have a negative sign outside the bracket, so if you take that negative sign inside the bracket, so you have to change the sign of all the terms inside the bracket. Now 9n square minus 9n square cancel out, positive 1 negative 1 0, so 6n plus 6n will be 12n. So you can see this number is a multiple of 12, and hence proved the difference of these two squares is a multiple of 12. Okay, so the next question, number 4, is n is an integer. Prove algebraically that the sum of n times n plus 1 plus n plus 1 is always a square number. So in this question we need to show the sum of these two numbers. Sum means add. If we add these two numbers, we should have a square number. Okay, so let's add these two numbers. So it is n times n plus 1 plus n plus 1. So if you take n inside, so it will be n square plus n plus 1. So it will be n square, n plus n will be 2n plus 1. So we can see, if we factorize this number, I guess we can do the factorization from here. It's easier to do from this time. Yeah, so if you take n inside, so n times n is n square, so n times 1 is n, so n plus 1 is as it is. So if you n times n plus 1 plus n plus 1. Okay, so if you take n out from these two and 1 out from these two, if you take n factor out from these two, so it will be n times n plus 1, and if you take 1 as a factor out from these two, will be 1 times n plus 1, because there is nothing common in these two terms, so we can take 1 out, 1 as a factor out, because 1 times these two terms will be same again these terms. Now in the whole expression we have n plus 1 and n plus 1 same terms, same factors, so we can take this out. N plus 1 times, from the first we can we left with n, and from the second term we left with 1, so it will be n plus 1 times n plus 1, so it will be n plus 1 whole square. So you can see the sum of these two terms is a square number. So the next question is, prove that 2n plus 1 whole square minus 2n minus 3 whole square is always a multiple of 12. This is a same question. We just need to open these squares. I mean, we can write this number like that 2 times as a product, and minus the next number we can write as a product, and we can do the term by term multiplication, and at the end we will left with the expression which is a multiple of 12. So you can try this question by yourself. It's a very easy question. Okay, the question number 6 is, n is an integer. Prove algebraically that the sum of this and that is always a square number. So we have n plus 2 times n plus 1 plus n plus 2. So we need to add these two terms, because it is given that the sum of these two terms is always a square number. So it is n plus 2. So if we take this factor out from the whole, if you consider this as a first term and that one is as a second term, n plus 2 is a common number. So if you take n plus 2 out from the first one, we left with n plus 1, and from the second one, since we take this n plus 2 out, we left with 1, so it will be n plus 2, 1 plus 1 will be 2, so n plus 2 again, so the whole thing will be n plus 2 whole square. So again we can see it is a square number. Okay, so the question number 7 is, prove that the sum of 3 consecutive odd numbers is always a multiple of 3. So in this question we need to prove that the sum of 3 consecutive odd numbers is always a multiple of 3. So we need to suppose let 2n plus 1 will be the first odd number, because when you sub n equals to 0 will be a 1, n equals to 1, so 2 plus 1 is a 3. So for every value for every integer value of n, you have the odd number. So the next odd number should be 2n plus 3, and the next should be 2n plus 5. So these are the three consecutive odd numbers, because for n equals to 0 it's 1, 3 and 5. For n equals to 1 it will be 3, 5 and 7. So these are the three consecutive odd numbers. So we need to show that the sum of these numbers is a multiple of 3. So 2n plus 2n plus 2n will be 6n. So 1 plus 3 is 4 plus 5 is 9. So we can take 3 out from this expression. So you take 3 out, it will be 2n plus 3. So you can see it's a multiple of 3, and this is the proof is done. Okay, so the next question is prove that the sum of three consecutive even numbers is always a multiple of 6. So let 2n, 2n plus 2 and 2n plus 4 be three consecutive even numbers. So if you add them, 2n plus 2n plus 2 plus 2n plus 4, so 2n plus 2n plus 2n will be 6n. So 2 plus 4 is 6, so we can take 6 out, and you can see it's a multiple of 6. So the proof is done. So that's it for today. Thank you so much for watching. Please subscribe our channel. Thank you.